Hi children, this is your physical science facilitator SS from Commander Group of Schools. Welcome to the online classes. Children, in the last session we learned some olfactory indicators. So it's about olfactory indicators that what we prepare onions. Okay? Onion pieces which has been finely chopped and kept in refrigerator. Now I am going to test with the help of base. Okay, first I have to smell it. Okay, onion smell, and after adding base. After adding base, again you have to smell it. The difference you may easily analyze. So like this we can prepare the olfactory indicators. Olfactory indicators means the indicators which change their odor, smell. Okay, these are natural indicator. Okay, so what is the density for this? For the blind people. The blind people can also easily identify the nature of the acidic and basic solutions. After that, one more thing we learned that the chemical reaction of acids with the carbonates and bicarbonates. When the acids are combined with metallic oxides or metallic bicarbonates, one gas is evolved. What is that? Carbon dioxide gas. What is the test of CO2? It changes lime water into milky layer. What is the general example? Whitewash. Okay, so learn the general day-to-day life example. How you are going to appreciate? Means AS6. In AS6 they are going to ask the appreciation questions also. Okay, at that purpose we have to analyze and how to apply the concept also. Now, let us come to the very important topic. Yes, certainly important topic about neutralization reaction. Okay, neutralization reaction. Let us see what is by neutralization first of all. Of course, by observing children, daily we are writing one probability to our science: dilute, salus, evaporate, what is filter, mistakes, and what you will catch? Crystals of success. So daily we are writing one problem related to science and how hard to apply to our life. Right, neutralization. The name itself indicates neutral. Neutral means the solution which has attained may not be the acid, may not be the base. But blindly, don't think like that all the salts are neutral. The nature of the salt is depend on the strength of the acid and base that what you are going to be used. Okay, we will learn in detail also. But don't think all the salts are neutral. Don't think all the salts are as neutral. They may be acidic salt, they may be basic salts, and they may be neutral salts. Based on the strength of acid and base. Right. Now let us see the definition of the neutralization reaction. Neutralization is nothing but when 1 mole of acid, combined with 1 mole of base is going to combine with whom? 1 mole of base. These two are going to combine with each other, 1 mole of acid and 1 mole of base. Why? To produce, they will produce. What they will produce? Salt and water. Water is a common thing in all the neutralization reactions. Besides this, salt is also formed. Their respective salt will form. But of course, certain amount of heat also will be released. The amount of heat released is depends on the strength of the acid and strength of the base. Now it is the definition of the neutralization. Let us see once again. When 1 mole of acid combined with whom? 1 mole of base. On what purpose? To produce salt and water. So when 1 mole of acid combined with 1 mole of base, it produces salt and water. Besides this, some amount of heat energy is released. So here, heat energy is releasing. So the chemical reaction which is accompanied with the release of heat energy is called exothermic reactions. Go means coming, sending out. Here also it is sending out. Exo, like that. So it is a chemical reaction, neutralization. It is also called, heat is releasing now, so called as exothermic reactions. Let us see one general example. Acid, one strong acid, hydrochloric acid, and one strong base, sodium hydroxide. These two are going to combine. 1 mole of acid, 1 mole of base are going to combine with each other. Then what happens? Immediately water will form. Water means H2O, hydrogen monoxide. Chemical name. What is the chemical name of water? Hydrogen monoxide. Mono means single. Only one oxygen is there. Hydrogen monoxide is the chemical name of water. Okay. Right. Now let us see what is the salt that is going to be formed. What is from here? H2O is formed. H2O is formed. Means here one H, and of course here one H, 2H and one O. So from here this OH is gone. From this hydrogen is gone. What is there now? NaCl. That's the solution. That's all is salt. That is the salt. NaCl. Sodium chloride. It is a negative ion now. Sodium chloride. All the negative ions are pronounced as oxide, chloride. So like this, right now, sodium chloride salt is formed. Besides this, 13.7 kilocalories of energy is also released. Understood? What is neutralization? Important. Maybe 2 marks, most probably 2 marks, and sometimes explained with different things. Maybe exo, maybe double decomposition. Like that, it may come for the 4 marks also. But what is the content you have here? When 1 mole of acid combined with 1 mole of base, they produce salt and water. In this reaction, certain amount of heat is also released. It is the example for that. HCl plus NaOH gives us NaCl plus H2O. So here, one more concept is there here. That's about if you see this one, this HCl. First, it will be decomposed as H plus and Cl minus. One decomposition, HCl decomposed. Similarly, NaOH, it is also decomposed as Na plus OH minus. Excuse me. Right. Now, this Na plus and Cl minus will combine. NaCl will form. And this H plus and this OH minus will combine. H2O is formed. If you see here, HCl, one decomposition reaction as H plus and Cl minus. And NaOH, Na plus OH minus, another decomposition reaction. So here one decomposition, here another decomposition. Totally how many decompositions are there? 2. Right. So that it is also called as double decomposition reactions. Double decomposition. So neutralization reaction is also called as exothermic reaction because heat is releasing. Neutralization reaction is also called as double decomposition reactions because two decompositions are going to take place here. Clear? Right. Now let us see with a activity about this neutralization reaction. Very important. Okay. Right. Let us see about that. For that, instruments first of all. One boiling tube and a holder. And I am going to take some base. What is this base? May see the sodium hydroxide. So sodium hydroxide. I am going to take some sodium hydroxide into this one. Yes, fuel of NaOH. NaOH is a strong base. I took this. Now, to this, I am going to add some acid. Okay, I am going to add hydrochloric acid. Before that, you should know whether it is a base or not. For that, I am going to add some indicator. I am going to add some indicator to this NaOH. Okay, right. Now, what indicators? So many indicators are there. Methyl argon I used. Or phenolphthalein. Oh, you like big car? Okay. I will add phenolphthalein to this Okay. Yes. It's pink in color means certainly that is a base. Now, to that basic NaOH, I am going to add HCl. Okay. Hydrochloric acid. Observe the color. What is happening to this color? See the color. See the color. What is happening to that? Children, have you observed? Very good. It becomes colorless. It becomes colorless. Why? Yes, because it is a acid. What is the color of phenolphthalein in acidic medium? Colorless. Now, let us see directly that reaction. What happened when acid and base is combined with each other? Right? Some amount of base and some amount of acid, few ml of acid. Okay, now the reaction is going to take place between these two. Yes, it's a highly diluted one, and when you touch this, it's warm. After some time, few more is it's going on. The reaction is going to take place. Now, after that, you may observe the salt which is going to be present in it. Okay, you may observe salt is going to form there because it is a highly diluted one. So, the preparation of salt is very slow. Okay. You see the body. Okay, salt is going to form there. Right. So that's about neutralization reaction, and it is exothermic also. When you touch it, it gives somewhat heat. Okay, children. Have understood now what is neutralization reaction? So, when 1 mole of acid combined with 1 mole of base, they are ready to produce salt and water. Here it is going to release, so that it is called exothermic reaction, and double decomposition, because 2 times decomposition is going to take place, so that is also called as double decomposition. Like that, you may take so many examples for this. But if you take, already I told you, yes, we'll take one more example like this. Have understood this? How the reaction is going to take place and how it's going to split. Now I am going to take CH3COOH. What is its name? While the page number 21, I think so, one table is there. But I am going to explain that. Already I told you that its name. Acetic acid, CH3COOH, acetic acid. 5 to 8% of acetic acid is also called, very good, vinegar. It's about vinegar. But it's a very weak acid. It's a very weak acid. To this, I am going to add NaOH. Same, first water will form. How the water will form? Here it will be decomposed now, like this. CH3COO minus and H plus will form. What about this one? Na plus Cl minus will form. Okay. First, NaOH minus will form. First, what happened? This H plus and OH minus will combine with each other. 2 H's and 1 hydrogen. So, water will form. So, water is formed. Now, what happened? This Na plus will combine with this COO minus. So, what is that? CH3COO CH3COO Sodium acetate is a salt. And besides this here, 13.4 kilocalories of energy is released. 13.4 kilocalories of energy is released. Here first decomposition, here also decomposition, and like this salt is formed, water is formed. If you see this reaction, what is the amount of heat released? 13.7 kilocalories. But in the case of this, only 13.4 kilocalories. Means 0.3 kilocalories of energy is shortage with respect to this one. Why? Why it is going to happen like this? If you answer those questions, you should know the strength of acid. Strong acid, weak acid, strong base, weak base, like that. Actually, that concept is there in our textbook after pH. But here, we need that. How it is going to happen. So, here I am going to explain about that again later with respect to pH also we will discuss. Have understood about this? Acid, base. Here it is a strong acid. Strong acid. It is about strong base. When strong acid react with strong base, 13.7 kilocalories of energy is released. Here if you see it is a weak acid. And what about this one? Strong base. Weak acid, strong base. So whatever the salts which is released here should be basic in nature. Basic in nature. Okay. So don't forget one thing. Based on the strength of the base or maybe the acid, the nature of the salt is going to be different. So the nature of the salt depends on two things. That is about strength of acid, strength of base. So based on the strength of acid and strength of base, the nature of the salt is dependent. Okay. Now let us see why it is going to happen like this. If you want to know why there is some change in the difference, the amount of heat, we should know strong acid, strong base, and etc. Right? We will say about it. Have understood neutralization? Yes? Anyone? That's correct. When 1 mole of acid react with 1 mole of base to produce salt and water. Why it is also called exothermic? That's why the heat is released. Why it is called double decomposition? Two displacements are going to take place. Now, the amount of heat released is not equal in all the cases. Because the amount of heat released is depend on the strength of the acid and strength of the base. Not only that one, the nature of the salt in neutralization is also depend on strength of the acid and base. Now let us see strong acid. What is a strong acid? Okay. Strong acid is strong base, weak acid, weak base. Very easy definitions, all are easy definitions. If we take any one acid, if it is completely ionized in any aqueous solution. Aqua means, what is the aquarium? Yes, aqua means water. In aqueous solution, means water as the solvent. If water as the solvent, what we call it? Aqueous solutions. Right. So, if we take any acid, if that acid is completely ionized, means it has to decompose into ions. If we take 100 molecules, 100 molecules has to be decomposed into the ions. For example, I am going to take one acid here, H2SO4. What is its name? Sulfuric acid. What is the common name? King of acids. In aqueous solutions, what happened in aqueous solution is the presence of water. It will give as H plus ions and of course HSO4 minus or maybe 2H plus and SO4 minus, like this. So if we take about 100 molecules or 100 molecules of H2SO4, here it will give 100 H plus and about 100 SO4 minus. Means completely ionized. If you take 50, 50 will come. If you take 30, 30 will come. If you take one more example for this, so sulfuric acid is a strong acid because it is completely ionized. What is the definition of strong acid? The acid which is completely ionized or 100%. The acids which are 100% are completely ionized with the presence of aqueous solutions. If you take HCl, how many I am going to take? 100 molecules of HCl. How many? 100. What happened to this one? It will decompose as H plus and Cl minus in the presence of aqueous solution. H plus Cl minus. 100 is decomposed. So 100 H plus will be there, 100 Cl minus is there. So totally it is decomposed. So the acid which is completely ionized. If I take only 20, what happens? 20 HCl molecules I took, then what happened? 20 H plus and 20 Cl minus will form. If I take 200 H plus, 200 Cl minus. So if I take only one H plus, 1 Cl minus. So strong acid means the acid which is completely ionized in the presence of aqueous solution. Okay, right. So now tell me what are the examples of this one? Yes, sulfuric acid, hydrochloric acid, nitric acid, NO3, nitrates, CO3, carbonates. Here also nitrate, but don't forget about that. All the nitrates are dangerous. Most probably, explosives nitrates are going to be used. Nitrates, explosives. Right. Now these are the strong acids. Understand what is strong acid? The acid which is completely ionized with the presence of aqueous solution. If we take 100 ions has to be formed. 50 ions like that. Now weak acid. Weak acid. Weak acid means the acids which are ionized less than 100%. The acids which are ionized less than 100% in aqueous solutions. That may not completely ionized, partially ionized. The acids which are incompletely ionized are less than 100% ionized, where in the presence of aqueous solution. Those are called as weak acids. Right. Less than 100%. Example, already you know about vinegar, CH3COOH. If we take 100 molecules, how many? 100 molecules of CH3COOH. But surprisingly, we are getting 78 CH3COO minus and 78 H plus ions. So it is not completely ionized. It is not completely ionized. How many molecules are you? 100. But only 78 molecules are decomposed. What about the remaining 22? They will be as usual as the acetic acid molecules. Clear? Have understood? How many molecules are here? 100. But how many ions? 78 CH3CO minus ions and 78 H plus ions. So out of this 100, only 78 molecules are decomposed, remaining are as usual. Okay, for example, I am going to conduct so many slip tests, but all the children may not get 100. The children who got 100 are strong in the content. Who are unable to get 100, they may be weak in the content. So, okay, here totally they are ionized. Here only 78 are ionized out of 100. So, acetic acid is going to be considered as weak acid, correct? Okay. Now, strong base. I think you have understood what is strong base. You can define like this one. The acids which are completely ionized, instead of acid, what you have tried? Base. Yes, can we? Okay. So the bases which are completely ionized are 100% ionized in the presence of aqueous solution. The bases which are completely are 100% ionized in the presence of aqueous solution. Then what we call them? Strong bases. Example of the strong bases, of course, here 100% are going to be ionized, equal to 100%. NaOH, sodium hydroxide. KOH, potassium hydroxide. Of course, calcium hydroxide. And so on. These are the strong bases. How can we say that these are the strong bases? Because if we take like this 100 molecules or 100 molecules of NaOH, then what happens? 100 Na plus will come and 100 H OH minus will come. 100 Na plus or 100 OH. So completely ionized. The bases which are completely ionized in the presence of aqueous solution. Right? Now I am going to take about weak base. Okay? Is that okay? Yeah. So, anyone can define that? Weak base. Weak base. What is weak base? That's not very good. Less than 100%. Right. The bases which are incompletely or less than 100% ionized. Less than 100% ionized. What we call the weak bases. Example of the weak bases is about ammonium hydroxide. Okay, this is very important. Ammonium hydroxide. Again, after few gases and one more thing, chemical bond also will learn about this. Ammonium hydroxide. Okay, let us see why it is called weak base. I will take 100 molecules of NH4OH. Then what happened? It's about 81 NH4 plus and 84 OH minus will come. Like this. What about the 81? What about the 19%? The remaining 19 will be as usual ammonium hydroxide. Clear? So here strong acid, strong base, weak acid, weak base can be defined with respect to the ionization. Okay. Right. After hydrolysis we are attaining that how many number of molecules right. Now let us see before that one equation. Yes, we will see HCl combined with who? NaOH to produce salt and water. What is the salt? NaCl and water is formed. Besides this, heat energy is also released. What is the heat energy? 13.7 kilocalories. But if you see here one more example, CH3COOH plus NaOH gives rise to CH3COONA plus H2O and then 13.4 kilocalories of energy. Why? How the difference is going to occur? Of course, in competitive examination also that will be asked. This one. Right? So here, NaOH. NaOH is strong or weaker? Strong base. Strong base. So what happened? 100 Na plus will come and 100 OH minus will also come. What about this one? Here 78 CH3COO minus and 78 H plus will come. Now this Na plus wants to combine with the CH3COO minus and this OH wants to combine with this H plus. Out of this 100, how many will come? Out of this 178 OH minus will come and they will come like this one. What about the remaining 22 OH minus? They will be as usual like that. And here also 78 Na plus is there. They will come and combine with the 78 only. Remaining 22 Na plus will be as usual. They have to combine. How they will combine? There is no ions to combine. For that purpose, out of 13.7 kilocalories, 0.3 kilocalories of energy. 0.3 kilocalories of energy is used. Okay, analyze the concept, very important concept here. How many molecules are there without ionized or without forming the ionization? So, already 22 CH3COOH is there. They are not ionized. If you want to ionize, we have to increase the temperature. We have to heat it. But here already 13.7 kilocalories is there. Now out of that, 0.3 kilocalories is utilized by this 22 molecules of CH3COOH and they will decompose. Have understood? So previously, of course, 13.7 will be there, but out of the 13.7, this 0.3 kilocalories of energy is used to ionize the weak acid present here. If you take weak base, then weak base. So if you want to ionize completely the remaining molecules which are there, to ionize that, we need heat. So that out of the 13.7 kilocalories, 0.3 kilocalories is utilized by the weak acid. So that the weak acid, the remaining molecules are also decomposed. Then they will be combined with this one and formed. So here the amount of heat liberated is reduced because the presence of weak acid or maybe weak base. Clear? Important one. Okay, in competitive type of questions also they may come. Okay, ma? If I take another one also, for example, HCl and NH4OH, in that case also less than 13.7. Okay, and also the nature of the acid and base will be. So you see that one also. So neutralization reaction, acid of acid and base combined, salt and water is formed. Simple thing. Acid and base is salt to water. Okay. Now, certain amount of heat energy is released. It is less. Why it is less means to ionize the weak acid or maybe the weak base, that amount of heat energy is going to be released. The question may be asked like this: what is the amount of heat energy released when strong acid combined with a strong base? Strong acid, strong base. How much? It's equal to the 13.7 kilocalories. And what is the nature of the salt? Nature of salt. Nature of salt. Strong, both are strong. So here the thing which is released is neutral. So when strong acid or strong base is combined, 13.7 kilocalories of energy is released and the salt formed is neutral. The nature of the salt which is formed here is neutral. Okay. Now, if I am going to take about the strong acid and weak base. Strong acid and weak base. What is the amount of heat liberated? Less than 13.7 kilocalories. Less than 13.7. Okay, don't get confused. Less than is just like L. Just like L is less than. Okay, less than 13.7 kilocalories. Which may confuse about less than greater than also. So now I am going to take one more thing about nature of, okay, strong acid, weak base. Strong acid, weak base. So the salt which is formed here should be the nature of strong one. So strong. What is strong here? Acid. So here the salt which is formed is acidic salt. Acidic salt will form because strong acid. Right? Let us see weak acid or strong base. Weak acid or strong base. In this case, what happened? That time also less than 13.7 kilocalories of energy is released. Less than 13.7 kilocalories. Now, nature. Now see what is it strong here? Acid or base? Base. So what is the salt here? Basic salt. Basic salt. So even though it is a neutralization reaction, in all the neutralization reactions, the salts which are formed is not neutral. The nature of the salt is depending on the strength of the acid or base. If I am going to take one more here, like this, weak acid plus weak base, then certainly less than 13.7 kilocalories of energy. Only in one case, strong acid, strong base is 13.7, in the remaining cases less than 13.7. Okay? Only one case, 13.7 kilocalories, there is about strong acid or strong base. Now, less than 13.7 kilocalories. Tell me the nature. Weak. Both are weak. So, neutral. Both are equal. No? So, the neutral salt will form. So, the nature of the salt is also depends on the strength of acid or base. Okay? Right. I think you understood how to define this and how to analyze this one. Strong acid, strong base, strong acid, weak base, like this differentiation and the nature of the samples. Right? Now we'll see one more chemical reaction of the acids. Okay, ma? For example, I am going to take ammonium hydroxide and HCl. Ammonium hydroxide, HCl. What type of salt? Acidic. Very good. Because ammonium hydroxide is acidic. HCl is strong. So the salt which is formed should be acidic. Now, what happens when the metallic oxides combines with acids? In this case also, salt and water will form. Salt and water will form. Any relation is there like this previous one? Acids and bases are combined, salt and water will form. Acids, bases will combine, salt and water is formed. Here also salt and water is forming when acids are combined with metallic oxides. Already I told you that. What is the nature of CaO? Ca. Calcium, oxygen. Calcium oxide, metallic oxide. What is the nature of metallic oxides? Basic. Finish. So metallic oxide is the basic in nature. Base is going to combine with acid. Base, acid. Salt, water. Okay. So metallic oxides are also. What is the nature of metallic oxides? Basic. Now you may take of course, in our textbook they give copper oxide. Take some copper oxide in a test tube, and add some water to it, then you will get copper oxide solution and observe the color. Now add some hydrochloric acid. First what you are going to take? Copper oxide plus water means aqueous. Okay. Now for this I am going to add HCl. Hydrochloric acid. The salt plus water will form. First water, then water. H2O, whatever H is there. So suddenly should be 2. H2O will form. Now what is that? 2 Cls and 1 copper. H gone, O gone. Cu, Cl. Cu, Cl. How many chlorines here? 2. And balance of copper is also 2. So Cu, Cl2 is formed. Now if you observe this one, the color of this one is about greenish. Okay, so like greenish, not greenish actually, bluish green. Bluish green. Don't forget one thing, colors are very important. In matching, mostly out of the half mark questions, some matching questions will be there. No? Most probably 8th or 10th question they will give as a matching. Okay, there most probably chances are there. Colors and units. If they want to test about physics, numerical values, units, and in the chemistry most probably colors. Okay, for that colors are important for us. So when you observe this one, the color of this one has changes into bluish green. Bluish green. Okay, so here also what is happening? Salt is forming and water is forming. So it is also just like the neutralization reaction. So why? Because the metallic oxides are also basic in nature. If you want to conclude that, it's the best one. Clear? Okay. It's about the class today, and we will see once again what we learn about olfactory indicators to check about that, and neutralization reactions. In that neutralization reactions, exothermic, the amount of heat is not same because the strength of the acid and strength of the base. Based on the strength of the acid and base, different nature of the salts. Here don't forget the nature of the salt is depending on the strength of the acid or maybe the strength of the base. And strong acid, strong base, weak acid, weak base also we discussed. If the acid is completely ionized in the presence of water, means an aqueous solution completely ionized is called strong acid. The base which is completely ionized is a strong base. If the reaction takes place with a strong acid, strong base, neutral salt, weak acid, weak base, neutral. Strong acid to weak base, acidic salt will form. Strong base to weak acid. strong base, so basic salt. So like that the nature of the salt is also identified given to that. Now metallic oxides are combined with acid, salts and water. Here color of this one is important about bluish green. Okay, so follow the textbook and underline the keywords, all the things. Okay, have a nice day.